witches and wizards of magical making and excellent eerie electronics. It's Professor Gallagher, and perhaps, like me, you've been asked to teach Defense Against the Dark Arts. Or you just want to make a cool project with an animated eye. In either case, in this lesson we're going to learn how to make this portable MadEye prop. Now, while our previous lessons have focused on learning electronics programming in CircuitPython, the content for my university physical computing course, or learning SwiftUI, the content for my university apps course, this lesson is made up of using someone else's code. In fact, we're not even going to use our usual CircuitPython. We're going to use Arduino on an Adafruit Feather M4 Express, a small board with pass-through battery charging. Perfect for a portable project, but I'll discuss the parts that I've used, where to get and how to use the software files, and you can adapt the code and parts for your own projects. So let us magic up something awesome. Now first, a quick shout out. When I wanted to work on a MadEye style prop, I ran across Erin St. Blaine's Eye of Newt project on the Adafruit Learn site. Erin is a professional cosplay performer as well as a maker, and she has a bunch of very well-written tutorials on the Adafruit site and elsewhere. Now, the software she uses for eye animation is the Adafruit Uncanny Eye project. It has lots of different types of animated eyes, and this was written by Phil Burgess, who is also known by the alias Paint Your Dragon. Thanks to you both. So here are the parts I've used in this build. Feel free to adapt them. The board I'm using is the Adafruit Feather M4 Express. I chose this board because it's tiny, it runs the Uncanny Eyes Arduino project, and it has pass-through charging. That means that you can plug a lipo battery for this into the portable project, but if you plug the board's USB port into a power source, the battery will recharge. Pass-through charging is awesome. You don't have to unplug the JST battery and recharge it, then plug it back in. And if you've ever worked with these batteries before, you know the JST connectors are really fragile, so minimizing unplugging and replugging is a good thing. Now I'm showing a 1200 milliamp battery here. You can use other sizes as well. I found this is a pretty small battery, but it gives a few hours of portable operation to get you through Halloween or a party, and if you are worried about losing juice, you could buy extra batteries to swap in. Now I also use this on-off switch to turn the battery on and off for portable operation. There are smaller ways to wire up the switch, but I had this part around and it didn't require any extra soldering. For displays, you've got a couple of choices. I've built two versions of this project, one with the OLED, which is larger but more expensive, and one with a TFT display. Adafruit says OLED displays have a half-life, but I've been using mine on and off for a few years and I haven't noticed the display burn out. If you do have a project that's always on, you probably want to use a TFT instead. I built a version for a mannequin head in my office that I'm going to have always on, and I'm using the TFT one for that. Now, the TFT display is smaller at 1.44 inches instead of 1.5, and if you use this lens I show up here, you might notice the sides of the smaller TFT display when viewed through the lens. You can't really see the sides with the OLED. Now I'm going to be wiring up a TFT display, but I'll show you a side-by-side using an OLED display that I've built already. Now everything is pretty much the same for the OLED display and the TFT. The pins on the two displays pretty much have the same name. The one thing that you want to change is a single line in the configuration code. I'm going to point this out when we get to it. Now I also bought this lens in metal housing that I found on Amazon. It was inexpensive, it was cool, it fit over the display. The tabs on the side are easy to bend at 90 degrees so you can mount them to a housing. I also designed and 3D printed a housing to hold the board. It fits both types of displays, and you can find a link to the 3D files in the lesson's description. Now I put a piece of white packing foam between the housing and the board. This pushes the board up so that it touches the lens. I think that gives a nicer look. And the foam also gives something for the M3 screws to bite into so that I can screw the metal lens mount into the housing. I also used an old leather belt, 28 gauge wire, solder, heat shrink, flux. You'll want Kapton tape or electrical tape to cover the electronics so that they don't touch the metals in the lens housing. You'll want glue, sticky-sided Velcro tape. That's what I used to attach the two pieces of the belt and back. I used a piece of fabric to house the electronics attached to the belt, and you can make a little pouch, sewing, using glue, fasteners are all possibilities. Oh, and one thing I forgot to mention that should be obvious, but if this is your first build, you do need a micro USB cable to plug into the Adafruit Feather M4. Make sure this is a data cable. Some people use charge-only cables that they might have with a battery backup. If you try using a charge-only cable instead of a data cable, your board and your computer won't be able to talk with each other, and you won't be able to program it. Now, if you run into any build issues, especially around wiring or the software, I'm not the best person to ask for tech support, but Adafruit has world-class tech support on their Discord channel. I use them all the time. Feel free to check it out. They also have forums on the Adafruit website too if you have specific questions. So the first thing I recommend that you do is to set up your Arduino software to work with your board and to run the simple Blink program, or Sketch as they're called in Arduino land, so that you can make sure that your board is working. Now, the Adafruit quality control is great, but I always test it every every stage of the build so that I can better locate any problems if anything goes wrong while I'm working. Now, every board Adafruit sells has a learn guide. This is the one for the Feather M4 Express that I'm using. If you have an older board lying around, or if you bought it from a shop that had old inventory, check to see if you need to update your bootloader, but if you bought a new board from Adafruit, you should be fine. Then jump to the Arduino IDE setup to get the software that we need to put the right program or sketch on your board. So click and install the Arduino IDE if you haven't done this already. It's free. And this section describes how to get the software for Adafruit boards that run Arduino. Now simply highlight and copy this entire URL, then head over to your Open Arduino software, and under the Arduino IDE menu, there should be a settings or preferences, I think it's called under Windows. Select this. Now, I'm using a version later than the one shown in Adafruit documentation, so my screen looks a little bit different, but in either case, you should be able to find this area that says Additional Board Manager URLs, and paste the URL you just copied right in here and click OK. Then back in the browser, click to head to the next page on using the Arduino IDE. And next, we're going to install support for the Arduino SAMD boards and the Adafruit SAMD boards. SAMD is just the type of chip that's on the board, so we're making sure we have the right files to make sure that our board can run the software we want to install on it. So to do this, head back to the Arduino software, and under the Tools menu, select Boards and then Board Manager, and you'll see a side panel show up on the left, and in the search box type in Arduino SAMD, and you can see that mine's already installed, but if yours isn't, install it now. Then change the search term to Adafruit SAMD and install those files if you need them. Then you can hide this install column by clicking on this icon here in the left-hand side of your screen. Now back in the browser, under this blink area, I'm going to click the Copy Code button here. This copies test code so that I can paste it into my board. After you click Copy Code, it'll say Code Copied. And next I'm going to return to the Arduino software and quit out of it. Now I'm going to plug in my board, and you can see that I cheated a little bit and broke my rule here. I started soldering wires on the board before I checked it. Your board doesn't have these wires on it yet. Now make sure that your board is plugged into your computer, and as always, make sure you're using a micro USB data cable. Some cables are charge only. You want to make sure you're using a data cable or your board won't receive files from your computer. And when you plug your board into your computer's USB port, you should see some lights flash on the board to indicate that it's getting power. Now with your Arduino software restarted, head up to the Tools menu and select Boards, Adafruit SAMD boards, and be sure to find and select the correct board. For us, that's Feather M4 Express. There are other Feather boards. There are other M4 boards. Make sure you got Feather M4 Express. Then head back under the same Tools menu, but this time select Port, and you should see one that says USB modem and some numbers, and it should say the board type. So select this. You'll also notice that the board name appears in the pull-down menu at the top of the screen. Cool. And now I'm going to highlight all of the code that we see on screen, and I'm going to paste over the blink code that I copied from the browser. And now that we've got the code in here, let's upload this to our board. So to do that, we press this little triangle play button up here. If you hover your cursor over it, the tooltip says upload. Now, one important caveat that isn't explained very well. I found that on my Mac, sometimes I got a red error 1 saying that the sketch couldn't upload properly. If this happens, double tap the reset button on your board just before tapping the play upload button on your Arduino software. This almost always fixes the issue. I'm not sure why you need to do this, but I spent a few hours trying to figure out what was happening, and this double tap reset thing seems to fix the problem. Now, if this is working, you'll wait a few moments, but you should see some white lettering scroll through on the console window below, and if this happens, your upload is okay. You don't need to double tap. And when this works, if you take a look at your board, you should see a red LED light flashing, 1 second on, 1 second off. Now, I usually also make a quick change to the sketch to upload that, just to make triple sure that everything's working okay. So there are 2 lines in here that say delay 1000. One will keep the light on for 1 second, the other turns the light off for 1 second, and I'm going to change those to 250. That'll just blink the light at 1/4 second intervals. So I'm going to go up here to the upload or play button, press that, and haha, look at that. I get this upload error status 1 that I told you about, but we know how to fix it. Just double tap that reset button on the board, then click the play upload button again in your Arduino IDE, and after a moment, the upload works fine. And if we take a look at the board, we can see it's flashing in 1/4 second intervals. Cool. Now that this is working, let's wire up and solder up both our display and our board, and then we can come back and get the sketch and get our eye working. So here's a wiring diagram you can keep up as you're doing your wiring. This matches the Feather M4 board of the TFT display. Now Adafruit does have a learn guide for electronic animated eyes, and there's a wiring section in here, but the wiring diagram that's shown does not include Feather boards. Now this diagram shows wiring for the Teensy board that has pins 8 and 7 for reset and DC, but these pin numbers aren't available on Feather boards, so we have to make changes to these pins. I'm using 11 for DC and 12 for reset. Also, you'll have to make changes to the config.h file in the final sketch that we use. I'll show you how to do this later. We just need to make sure we set our new pin numbers on the Feather to the DC and reset value in our config file. So I have not been trained with an electrical engineering background. I have degrees in computer science, information systems, and business. So I've never had a formal electronics mentor. So I'll share a bit of advice that I've learned along the way that I wish I knew when I started. And the first is get a good set of helping hands. I've tried a bunch of different versions, and the one that I like the most is this one here from OmniFixo. They're not paying me for this, but I think it's the perfect size for most projects. The clamps are magnetic, they're really easy to slide around in position, and they keep their location nicely. The clamps have the perfect tension, they're coated to avoid board damage, they're much better than the bendable helping hands that I've seen most folks use. And another thing that I wish that I'd known from day one was that soldering goes much easier if you use liquid flux. Now, I am awful at soldering. I have terrible vision, so bad I can't drive a car. And by the way, if you need vision help when soldering, I use these glasses. They work great, but put some tape around the lens base, otherwise they fall out easily if you tap the lens by accident. But with flux, if you squirt a little bit to coat both the contact hole on the board and the wire, it looks weird because it looks like you're making a mess, but it helps assist the solder in finding and adhering to the metal during the bonding process. It's a huge improvement in soldering. Definitely use liquid flux. Some folks clean up their flux after they're done soldering, but I never find that I need to do that. It's up to you. Also, before soldering, melt a bit of solder on the tip of your soldering iron. This is called tinning your soldering iron tips. Then tap or gently scrape off any excess on the steel wool before continuing. Make sure you don't tin your tips over your board or you might drip some on your electronics. I think I've made every single error that makers can make, so hopefully this advice is helpful for you. These things should really help improve your soldering game. So here's the display soldered up. Again, I'm not great at soldering, and full disclosure, I make plenty of mistakes, so don't feel bad if you make mistakes. I was distracted and I actually soldered my ground wire to 3 volt on this board. I had to snip it off and then put it in the right place. Again, even though I have a PhD and I teach this stuff, I am terribly clumsy, so hopefully my advice helps you avoid a bunch of dumb mistakes. Now also, you might see some folks use ribbon wire and then just separate the ends out to wire to the display and the board. That's not a bad idea either, but I'm using individual wires. And I'm actually soldering one set of wires to my display and another set to the board, and then I'm going to solder the 2 wires together. I think this is a little bit easier than stretching out a precise set of wires that goes from my display and then working in a really small space on my board. It's up to you. Do whatever you think fits your skill. So this is where we're headed next. I've got the Uncanny Eye code on my board and I'm testing things out. Now you can see things are working. We'll get here in a minute, but what I've done is I've taken 7 small Gator wires and I've clipped them to the separate wires on the display and on the board. Make sure none of your metal parts touch. This is going to allow me to install the software and test things out before final assembly. So now let's get the code we need to run the eye. You can find it on the internet by searching for this term, Adafruit Uncanny Eyes GitHub. And the first link will bring me to the GitHub repository for this project. Feel free to go through the README in case there have been any updates since this lesson was recorded, but I'm going to click on the green code button here and pull down and select Download Zip and save this to my desktop. Then I can minimize my browser, I can open the folder that I just downloaded, and then go into the Uncanny Eyes folder. And if I double-click on uncannyeyes.ino, this is going to open up the Arduino IDE software, and all of the code that I need to run this project is shown on my screen. So you can see across the top, you've got a bunch of tabs that are open, but the only one that we need is this one here, config.h. Everything else is written for us. Now by default, this sketch or this program is set up to work with a TFT display, which is what I've wired up, but if you're using the OLED display, make sure that you uncomment this line by removing the double slashes, and comment out this line for the TFT by putting 2 slashes at the start of the line. Now also, because I used a Feather board, I'm using different pins for DC or data and reset, so I'm going to change reset to pin 12 here, and I'm going to change DC to pin 11. That's how I've wired things up. And then if you notice up the top, there's also this information here that says if you're using a single eye, you might want to enable the line below. So that's what I'll do by removing these double slashes that you see here. And if you scroll, you can find that there are a bunch of different eyeball options listed. All of them are commented out except for the default. That's what we're going to use. But if you're curious about the other ones, you can certainly try them out one by one. Just make sure that you uncomment one and then comment out the last one that you were using. You can't have two of them selected at once. But if you want to see what they look like first, you can go back to Adafruit's Learn Guide for the electronic animated eyes for ARM controllers, and there's a section for ready-made UF2 files, and if you scroll through this, you can see the different eye types. Now the eye that we're going to use is the default eye, and it initially has a heavy lid on it, but I'm going to show you how we can change that in just a bit. Now there's one other important note down here. It says that there's one eye per line. I'm only using a single eye hooked up to pin 9 here, so I don't need this line with pin 10, which is what I would use if I had a second display up for 2 eyes. So what you should really do is comment this line out by putting in 2 slashes at the start of the line. If you don't do that, your code is still going to work, but it might run a little bit slower if it processes the code for 2 eyes instead of for only 1 eye. Now the comment above also says that the middle number is for a wink pin if you had a separate controller to make the eye wink on demand like a little button, but we're not using that, so we should put a -1 as the second parameter in here after the 9. So now let's upload this sketch to our Feather board. So we'll click on the Uncanny Eyes tab, and let's make sure that the proper board is selected. So under Tools, select Board, Adafruit SAMD boards, and find and select Feather M4 Express. And then we want to make sure the port is selected properly too. So we'll go under Tools, Port, and select the option with Adafruit Feather M4 Express as well, that one with the USB modem. And we see our pull-down menu up here now shows our board, and we should click the play button to upload our sketch to our board. I'm going to speed things up, but initially I got the upload error number 1, but we know how to fix that. Just double tap the reset button on our board and then click the play button again, and the upload works. It takes a few moments to get there. You'll see a lot of text race by in the console. That's just because this is a big sketch with lots of information for animating the eyeball, but eventually you'll see it stop. And if you look over at your display, ho, it is working. It's winking at you. It's looking around. Nice. So now that we know that our code is working, we can continue with the final assembly. Next, I took an old belt and I sliced off the buckle and the belt holes and cut it in half. And this is going to be the strap that holds the eye and the housing in place on my head. And I glued the ends of the 2 pieces of the belt at a right angle using Gorilla Glue. This is where I'm going to mount the eye. Always work on something disposable because Gorilla Glue is really sticky. Now I also used Gorilla Glue to secure the plastic PLA print on my leather belt. Make sure that the open end is where you want your wires to go out toward your belt. Now back near my display that's going to act as the eye, one thing I didn't show, I'm sorry about that, is I put a piece of Kapton or heat-resistant electrical tape over my solder joints. You never want any electrical metal in your project to touch any other metal, and my lens mount is metal, so be sure to put some tape over where I've highlighted here. Also, I've used a utility knife to slice a hole in the belt near the 3D print where my wires are. Be careful and don't cut the wires. Then I carefully threaded the 7 wires from the display so that they went through to the underside of the belt. You don't want the wires on top. They're going to be hidden by the belt. And the 3D printed housing has holes for screws, but you don't want to screw these in and crush your board. I already did that. I ruined a $40 board. I'm making the mistake so you don't have to. But what I'm doing now is I'm putting a piece of packing foam inside the printed housing. Then I can put the display on top of it, and the screws are going to go right into the foam. So here's the eye assembly. I've got the housing, then the foam, my display is on top, then I put on the lens, then I put on the metal lens holder right on top. Now before placing the metal holder on top, I bent 3 of the tabs at a 90-degree angle. I just used pliers for that. This lets me use M3 screws to hold those 3 tabs in place in the 3 holes in my 3D printed housing, and the screws go directly into the foam, and that seems to hold fairly well. So I don't have any kind of nut inside. I just twisted the screws directly into the foam. So this means that the display is pushed up next to the lens, and it gives you a nice fisheye magnifying effect. Then figure out where you want your electronics to sit on your belt. I'm using a piece of leather that I got at a fabric store to act as a pouch to hold the electronics. So I'm going to fold this over, and I'm going to slice a hole in the side of the folded fabric where I can slide this inside the belt. So here you see I've threaded my folded over leather fabric through the belt, and I've super glued the bottom of this to give me a seam, so this is like a pouch. I'm not very good at sewing, so super glue works great for me. And I've also used a utility knife to cut a hole in the belt and the underside of the fabric, and then I carefully threaded through all 7 wires from the board so that they go through the underside of the belt. And now before I do my final soldering, I'm going to use alligator clips to test out the build, just to make sure that I didn't jostle any connections free. And it looks great. Next, you want to connect the wires that are going to connect the LED screen to the feather board, so you can trim the ends of the wire so that they're not too loose. You want to make sure that you can bend the wires a bit, but also tuck them completely underneath the belt. And very important, make sure that you thread some heat shrink tubing through one of the wires before you solder. This way, after the solder is done, you can slide the tube up to protect the soldering connection you just made, and you can use a heat gun or a match or whatever you use to heat shrink. Also, you should add flux to the metal connections here before you try to solder them. Here's our powered up eye, and it works. The soldering connections are made, the heat shrink protects the solder joints, and you can see that the wires have some slack, but I can also tuck them entirely under the belt, and you can use packing tape or any other adhesive to hold the wires down. So here's a comparison of the OLED display on the left and the TFT that I wired up on the right. And one thing that you'll notice is the TFT has a heavy eyelid that droops where the pupil is pointing, and the pupil was bigger on the TFT than I wanted. But I was able to improve things by poking around in some of the settings. So back in the config.h file, I found this line that defined tracking. It was uncommented, and this has the eyelid track the pupil's movements. When I commented this out by adding 2 slashes in front of this line, the eyelid no longer covered part of the eyeball, but it still blinked. That was the effect that I wanted. Now you can also mess around with these 2 iris settings at the very bottom, iris_min and iris_max. This is at the end of your config.h file. It might be that only the max does anything. Feel free to mess around with these numbers, but I set my min to 80 and my max to 275. Then I return to the Uncanny Eyes.ino tab. Make sure that your board is plugged into your computer and powered up. Then press the play button in your Arduino IDE to upload the modified sketch. Remember, if you get that upload error 1, you might have to double tap your reset on your board. But after it loads up the sketch, you should see your improved eye. This is how things look when I'm done, and I think this looks better than the default. Now I still have the OLED on the left for your reference, but on the right is the less expensive TFT display. Both of these look pretty good head on. I notice that if I move side to side, it looks like the OLED display looks better when viewed at an angle. Wider viewing angle is another benefit of using an OLED. Now one thing I don't like about the smaller TFT is that you can sort of see the edge of the screen. I'm going to try to add some black electrical tape around the edge of the display to try to hide the edge. Now here are the final parts of my build. I've added a very small USB cable attached to my board. You don't need this, but most of the time I'm going to keep my board plugged in. I'm going to keep my eye on mounted to a foam wig head, yet another cool prop from my office that I hope students like. And then I've shortened the cables on this click on off switch. It has JST connectors, the same connectors that are on the battery, so I can plug one of the connectors on this switch into the board and the other into the battery, and I can simply click this button on or off to power my project when I want to wear it without a USB connection. Finally, you can see I've got electrical tape over the wires on the underside of the belt to hold the wires in place. There's probably a better adhesive to use. Feel free to offer your best advice in the comments. And to seal the pouch, I simply super glued some Velcro to create a sealable flap. I tried using fabric snaps, but unfortunately my leather here is too thick for the snaps that I had. Again, feel free to share your improvement ideas, but Velcro is my favorite kind of grow, and I use the Velcro tape to create an adjustable seal in the back of the belt. I have a huge head, so I needed a smaller size to fit on the mannequin, and that's it. This is what the finished product looks like. I'd love to see what you built. Be sure to share online, tell others about the channel, like and subscribe will help me out, and if you built this, congratulations on making something awesome.